In this video, we're going to try and sum up this alternating series. So notice the pattern. You've got 1, 2, 3, 4, 5, 6, 7, all the way to infinity. So we're going to sum up this whole series, even though it's alternating, minus, plus, minus, and so on. Even though it's alternating, if you sum up the whole series, surprisingly, it turns out to be natural log of 2. So in this video, we're going to try and understand why, when you sum up this whole thing, it equals natural log of 2. And we also need to show that this whole series converges. We need to show that it converges and that it equals natural log of 2. Why does it equal natural log of 2? So that's our aim. So in order for us to do that, let's consider this function. So consider this function. This function can be viewed as a series. And remember, we've seen this before. Remember our series. Hang on. Remember this table. We've seen this table before. This function can be viewed as a series, provided absolute value of x is less than 1. We've seen this table before. So going back to here, consider this function. This function can be viewed as a series. So this series, you can visualize it as this. You've got 1, and then you've got your x squared, cube, and so on, to the power 4, to the power 5, to the power 6, and so on. And then your alternating component here. Your alternating component here shows up. Because look, it's minus, plus, and so on. So in order for us to show that the series converges, we need to break this up. We need to break this up into 2 separate blocks. So we need to break this up. So this block here can be viewed as this whole thing here, all the way to infinity. But in order for us to show that that the series converges, we need to break this up into 2 blocks. So now this thing here, we're summing up from 0 to n. So we are summing up from 0 to some arbitrary n. So that's this block here. And then for this block here, we are summing up from n plus 1 all the way to infinity. N plus 1 all the way to infinity. As it turns out, this whole block here equals this thing here. This thing stays the same; it remains the same. So in order for us to show that the series converges, we need to be able to understand how we got from here to here. Okay, so in order for us to see why the series converges, we need to understand this. So our next step is to try and understand how we can jump from here to here. Okay, so the way we do that is to consider, well, this block here is really us summing up everything to an arbitrary n, and then this is going all the way to infinity. It's not possible for us to go all the way to infinity, so we would just take it up to some arbitrary point p. Just take it up to some p. So in order for us to understand why we can jump from here to how we can jump from here to here, we need to consider starting from n plus 1 to p, and then later on we can take the limit as p tends to infinity. Okay, so our next step is to try and understand why we can jump from here to here. And the way we do that is to consider doing it from n plus 1 to p. Okay, so I will continue in the next video.